Okay, welcome to the phase change notes review. I'm just going to briefly whip through these notes again for hopefully another tool for you to be reviewing with from the matter test. So what are phase changes? Phase changes are first and foremost physical changes. That is a very key thing to remember. Physical change it's reversible. That is a major thing to remember. Because as you'll recall from the classification of matter video, so the chemical changes are not reversible. When you catch something on fire and it turns into something new, it is no longer reversible. It is, those new things forever. But phase changes are reversible physical changes. It's basically when it changes from one state of matter to another, solid to liquid or liquid to gas, and so forth. So anyway, well, how does it happen? Well, it all comes down to the one big word, the E word, energy. Energy is either absorbed or released during a phase change. And when I mean absorbed, I mean taken in, or energy is given off or released during a phase change. We'll get to in particular, the different phase changes. I'll discuss energy is absorbed in or energy is released. Temperature of a substance does not change during a phase change. That is a very difficult concept for people to understand. If you remember the heating curve graph that we did in class, the reason that the graph kind of plateaus, if you will, the reason that it does that is because it's showing that, it looks like this. This is kind of a horrible drawing, but the heat curve looks like this. And the reason that it's plateauing or staying flat like this is because it's showing that the temperature doesn't change when it's going from, let's say this is liquid and the gas is over here. When it's going from liquid to gas, and even when you have a pot of water on the stove and you're cooking something, when it's converting to gas or when it's vaporizing, if you will, it stays the same temperature until it's all gone. And that's kind of a difficult thing for people to understand. Why doesn't the temperature increase? Because the temperature doesn't increase because all extra energy absorbed in during this temperature is converting into the new state of matter. So that is why it maintains the same temperature throughout the entire phase change. And then when the phase change is done, then yes, the temperature is allowed to change again. So as I was saying, it's either absorbed or released. When energy is absorbed, it's called an endothermic change. An endothermic change is when it takes energy indoors or inside, right? That's the way I remember it, the prefix here. Endo is kind of, it is the prefix for in, to take in, right? Like when your mom calls for you and screams for you to come indoors because supper is ready, right? I know it's silly, but it works for me. Prefixes help me to remember what words really mean. So you take energy in. Melting ice is taking energy in, right? Poor snowman over here is not doing well. He's either had an accident or he's melting. I'm assuming he's melting. Plus he's kind of sweating. It looks like, I don't know if snowmen sweat, but if he does, it looks like he is. He's getting nervous. When the snowman takes energy in, like even say from the sun, right? As it absorbs energy into it, what happens? It starts to phase change. It starts to go through the phase change, and it will start to melt. Heat of fusion is a term required. Is basically it's a term that discusses the amount of energy needed to melt a substance. Ice has a heat of fusion amount. I don't even know what it is. That's really not relevant. But it's just a term that's really what it means. Exothermic change, its system releases energy. What I mean by system, it means like an object or a substance. Freezing, for instance, releases energy or puts off energy. So exo is the prefix again here, meaning to exit or to put off or to put out. Right, so that's what exothermic means. I said this earlier. Temperature doesn't change during the phase change. This will be 212 degrees. That's the temperature of water boiling until all the water's gone. So it'll continue to boil and continue to boil, and it'll continue to turn into vapor. And as it continues to turn into vapor, this water will maintain that 212 temperature the entire time. Why does the temperature not increase? Again, it doesn't increase because all of the extra energy that would be increasing the temperature normally is converting the water to steam. Same way with ice, or ice water in this sense, right? Let's get into like the types of phase change. These are pretty basic, and I assume you know most of these. Melting, phase change where substance changes from a solid to a liquid. Again, this is review at best. You know what melting looks like. You leave a piece of ice on the counter, it will turn into water. You know this. Why does it do that? Because it takes energy in from the atmosphere. That your house is probably 70 something degrees, right? Ice is 30 something degrees. Well, it's going to obviously take some heat into it. That's why Frosty's snowman. That's why he couldn't stick around. He's going to come around for another day, or whatever the song says. Freezing, phase change, where substance changes from liquid to a solid. Again, assume you know this one. Pretty easy. Continuing on with our phase change, you have vaporization. Vaporization is literally when something turns to a vapor or a gas. Water vapor or steam. So easy, again, associate something you know. It's a phase change where it turns from a liquid to a gas, right? If you have a pot of water boiling for your spaghetti, you will see vaporization going on. Takes place in the whole liquid. As in boiling water, vaporization is all vaporizing. It's all starting to vaporize. That's why it's bubbling. It's starting to turn into vapor or gas. That's the gas is bubbling from the water. So that's the reason you see the bubbles form on the bottom first, and then it's going all the way through the liquid. As that's a good example of how to remember vaporization. It takes place in the whole liquid. You see the bubbles all the way on the bottom of the pot. Evaporation is basically the same thing where liquid turns into gas, but it only takes place at the surface of your liquid. For instance, if you've ever had a glass of water sitting beside your bed for a week or so, you'll notice that the water is going down. And, every couple of days you'll say, "Oh, I didn't drink out of that," but it looks a little bit less. It's also why your fish tank miraculously loses water. If you ever had a fish tank or a fish bowl, it isn't like the fish are drinking it. It's evaporating from the surface. You're not vaporizing your fish, are you? You're not putting your fish tank on a stove and cooking it. I hope not, anyway. So it's evaporating only at the surface. Now the difference: vaporization, bubbles on the bottom, goes all the way through the pot to the surface. Evaporation, only at the surface. Condensation. Phase change where substance changes from a gas to a liquid. So this is kind of opposite to vaporization. So this is gas to liquid. Gas to liquid occurs on your Coke can, your soda can. I don't know if you drink Coke or whatever, but Pepsi or whatever. It's why your Coke can sweats. It's why your mom probably wants you to put a coaster or some kind of piece of paper or napkin underneath your Coke can, because condensation is going on. Because your Coke is really cold, and what it's doing is it's kind of cooling down the air around it. It's also visible with dew in the morning. That's why your grass is wet. Some other ones: sublimation, deposition. These are a little bit harder to understand because it's hard to quote unquote see them, but you actually can see them. You just don't see them on a day-to-day basis like you do melting. Sublimation's phase change where it goes from solid to gas, skipping the liquid entirely. Dry ice is the most easily understood example of sublimation. It is literally a chunk of CO2 in frozen state, but it completely skips the liquid phase and goes directly to the gas phase. And the reason it's called dry ice is because it sublimes or goes through sublimation. It does not turn into a liquid. It is therefore dry ice. You can put this in your cooler with your drinks and stuff, and let's imagine you got some delicious sandwiches in there, but you don't want your delicious sandwiches to get wet. So you don't put water ice in there because water ice will turn to water, hence the water ice. But dry ice will not turn to a liquid, so it will keep your sandwich deliciously fresh yet not soggy. Because what does it do? It does not turn to a liquid, it turns into a gas. So you'll open your cooler and it'll be like foggy and smoke will come rolling out of it, but your sandwich will be dry. So it's the best example I can provide. Deposition is opposite to sublimation, just like melting is opposite to freezing, and condensation is the opposite to evaporation or vaporization. But deposition is when a gas turns directly into a solid. And this, again, is not a common phase change that you see on a day-to-day basis, but you do see it on the mornings whenever you're going out in the winter and all of a sudden you have to scrape the windshield, or you see your mom or your dad scrape the windshield off of the car because it's frost. Frost is water vapor. It's in the air all the time, turns directly to a solid on your windows. And the reason it forms on cars, and especially the hood or anywhere else there's a large piece of metal, it's because the metal will get cold really quickly, and this gas or vapor that's right around the hood will basically freeze directly from water vapor into a solid directly onto this cold object, which is the metal car. And I believe that's it for our phase change notes. Hope it's helped. Catch you in class.